Hello students, my name is Sumit Mehta. So now in this lecture we will discuss about definite integral as the limit of sum. So what do you understand by this statement, like a to b affects dx? So a and b are the area in which this function is defined. Okay, is the area bounded by the curve? Let me draw the curve. Let's say this is the function y equal fx. Okay, and the ordinates x equal to a and x equal to b and the x-axis. So this is the area and it is shown by a to b integral fx dx. So this is the region, student, in which this area is divided. So now you can name it as p q s r. Okay, whatever you want. Okay, so the region PR SQP, this region is the area and between the x and the ordinates x equal to y. So now we can divide the interval a to b. So kindly notice that here is the closed interval a to b. These brackets shown a and b are also included in this area into n subintervals. N subintervals by, let's say, this is x naught, this is x1. Okay, similarly we can divide this x2 in this region, like x naught, x1, x1, x2 and so on, where this is x1, x2, x3 and x0 is your a, x0 is x equal to a, where x0 is a and x1 is a plus h, going on, and so n will become b minus a over h. Okay students, so we note that n tends to infinity for very small h and h tends to 0. Okay, so now to find out this integral, what we will do is I can write this as a to b fx dx as limit h tends to 0 h of fa. As you can see, these are the rectangular strips of very small size, so we can ignore this, like, so we are ignoring this area. Okay, so in this, if this is the strip and this is h and this is x2 minus x0, or you can say fa and fa plus h, so this will become fa plus n minus 1 times h. Okay, or I can also write this as b minus a limit n tends to infinity 1 by n fa plus h up to last term f of a plus n minus 1 times h. Okay, where h is b minus a by n, tends to 0 when n tends to infinite. So students, this is the area, this integral, definite integral as the limit of the sum represent this area. So I hope students now you're pretty clear about these small strips will represent these rectangular strips, like this is x2 minus, or you can say xn minus xn minus 1 into h. Okay, so this is your h, and this is like xn minus, or the height can be fa plus h, fa minus, fa plus n minus 1h. Okay, so similarly when you will multiply this b minus a over n, so this n comes here, so this is the total area that will represent this integral. Okay, and in the next lecture, student, we'll discuss some questions based on it, so stay tuned for that lecture. Thank you, students. Happy learning. Stay blessed.